Hello dear students, today we will study about chapter number 2, structure of atom. Structure of atom. In the previous chapter we have studied about atomic structure, Dalton's atomic theory, and that theory proves us very nicely that it says that atom is indivisible, and this concept was put forward many years ago by our Maharshi Kannad, who is known as Maharshi Kashyap. So in this chapter, what we are going to do, we are going to prove that Dalton's atomic theory was wrong, and the discovery of, let's have a discovery that we are going to study about discovery of electrons, protons and neutrons. Along with, we will discuss also certain structure, atomic structure given by different scientists. Atomic structures by different scientists. Okay, so whatever that we have to study, let us first see how this discovery of electron takes place. All of us are very much aware that like charges repel each other. It means positive when come together, they go far away from each other. Negative come together, they go far away from each other. But unlike charges attract each other. It means plus and minus comes together, they will be together over there. So what was that? It was the discovery of an electron, and the discovery of electron, it was like that Michael Faraday. We talk about a very known scientist, Michael Faraday. In 1830, he has given many, some rules and regulations by observing electrolytic cells, and observed that things which we will talk about that in 12th standard more about that. But he was the pioneer who was the first person to identify whether something is there within the liquid which is useful for us. Okay, so what he formulated certain laws which we will study in class 12. The results suggested the particulate nature of electricity. Okay, so what is that? The results, whatever the results come out from his experiment, inspire other scientists, and in the mid of 1850 scientists began to study electrical discharge partially evacuated tubes that's known as cathode ray tubes. Cathode ray tubes. About these tubes you will study more in physics, which is also considered as CRT. Okay, the CRT. Okay, you can see in one of the diagram given over here in the textbook, that is 2.1. It's what is that? They have given a one glass tube. It's look like this. It's a glass tube where they have a vacuum pump. Okay, this is what the vacuum towards the vacuum. It's a one glass tube like this, having two electrodes, two metal electrode. You can take any metal over there, and then it is connected to high potential electric current supplied from outside. Okay, so this is what, dear students, it's a very high voltage things they have taken. This is attacked as this is the one negative, that is called a cathode, and here it's a positive. I have taken a different one than the book, so that this numbers, this can be different. Okay, no problem. Here whatever they have studied about, this is what the electrodes we talk about. These two are the electrode which can be of any metal, and related to this, here they have captured any gas. Okay, the gas. Okay, what they did in this one, it's a glass tube with a too thin piece of metal called electrode sealed in it. This has to be sealed up. Okay, the pressure of the different gases could be adjusted by evacuation. This will be in a vacuum pump. This will be a vacuum pump where it goes to the vacuum. Okay, so that I can manage the pressure inside the tube, and then the electrical discharge through the gas could be observed only at a very low pressure. Now what they started working with it, at a normal pressure they started working. Okay, at a normal pressure they applied current, okay, high voltage current, but they did not find anything else. So what happened, they started reducing the pressure. At a one level, a pressure, it start glowing. There was the gas which started glowing over there. And again they go for the very low pressure. At a very low pressure, what happened, it applied is at a very sufficiently high voltage across the electrode. Current start flowing from the stream of particles moving in the tube from negative electrode. They see this is the negative electrode. From here they find something is moving, okay, and going towards the positive, and these rays they consider as cathode rays, as they are coming out from cathode. So the flow of current from the cathode to anode was further checked. Okay, how they check this? So they check this one, okay, whether this is the color, that is the current which is coming from cathode only or anode only, because they were not aware. So what they did, they make a hole in anode. અહીંયા એક hole કરી નાખ્યો anode પર, and then they coated the tube behind side, this is the one with a fluorescent. Okay, it's a phosphorescent material. Like here they have applied a zinc sulfide, okay, zinc sulfide, and then they started working. Then what happened, they from the hollow part they strike, and there was some kind of a bright spot developed over here. That was a bright very bright spot developed over here. This is the result which makes them understand that yes, particularly there are something which is coming out from cathode, and that rays are cathode rays. They give the name as a cathode rays. Now what was that experiment? On the base of this experiment, what they summarize that cathode rays are starting from cathode and moving towards. First observation that they summarize this, cathode rays are starting from cathode and moving towards anode. This is the first thing that they summarized. Second, this themselves are not visible. They are not visible, but their behavior can be observed with the help of a certain material. Okay, it's like the same thing, whatever that you can't see there anything over here, but when it was kept it under the fluorescent, they give a bright spot. Okay, so the television picture tube, the one which we use right now we are using, that is plasma TV. Okay, LED TVs are we using, but before that there was a tube like the cabinet and big tube like that. That was the same thing, the same function they were using. You might be studying this in physics. Okay, so we are now going to focus more on this. In the absence of electric and magnetic field, what they have observed, in the absence of magnetic and electric field. Now once they start come to know, okay, there is something which is going on, so they have not applied any electrical field or magnetic field. How does they look like? They travel in straight line. They traveled in straight line. This was the very bright observation done by them. Why? How they come to know this? Because the straight line, and they were getting the holes at a particular place. So that was the observation done by them, and that was that inference given by them. Then what happened, when they applied electric current, when they applied electric field, okay, electric field केवी રીતે આપી બેટા? Okay, it was like this, on this side, on upper side and the lower side they applied one part, positive, negative. Then they find it out that the rays coming out are going towards this side. They are moving deflected from their path and going towards the positive portion. Okay, so they sees this, since this one does. In the presence of this electrical magnetic field, the behavior of cathode was expected. Cathode rays are similar to the expected from negatively charged particles. So at that time in their mind, what was happened? They change. Okay, the rays, that is called cathode rays, deflected. Okay, they deflected their path, and that's why what are they behave as if they are negative, and this is how they come to know that cathode rays are negatively charge particles, and which was further known as electrons. They give them name as an electrons. And who was the person to investigate this? That these are the one. We can conclude that electrons are basic constituent of all atoms, and it depends on completely, do not depend on upon a material of electrode and nature of the gas present in the cathode ray. And who was the person? Then the person was J Thompson. This was the scientist who has explained this thing. On the basis of that, this credit of finding electron goes to him. No doubt he has companions along with him, but this was the thing which he has talked about. Now, this was the first British scientist in 1897. J Thompson measured the ratio of electric charge to the mass of electron. At that time, with the help of a sophisticated method, they were not able to find it out. So they calculate the mass of electron, and what they find it out, they calculate the mass of electron. So what is that? They have done a very nice tube. Okay, he has done an experiment. What was the experiment done by him? He tried to measure the ratio of electric charge to the mass of electron. That ratio is, we called it as a E by ME. Okay, this ME is called mass of electron. This ratio. How he did this one? So by using the cathode ray tube and applying electrical and magnetic field, you can see the very nice diagram given in a 2.2. So same diagram he has applied, and he finded out three different things. What happened? That anode बच्चे hold कर दीदू cathode में, and then he applied that, allowed that light to go, pass it on, and having a fluorescent screen where he applied, when a positive charge applied, the spot goes to the B portion and then the C portion, and that was happened in magnetic field, and they are deflecting. So with the help of this, when he find it out, okay, when electric current is applied, the electron deviated from their path and hit the cathode ray tube. It's like this. Okay, he has done this kind of, I'm just trying to make it out. What is CRT? That is called cathode ray tube. Okay, here is the anode, cathode, that he's talking about, a plate. Here is the big plate which we are going to talk about. That is what he talks about. This is my anode. Okay, and then from here he has expanded it as a cathode ray tube. This is CRT, kind of a material which he has used up over there. And then, dear students, what happened there? Here is one of the big fluorescent screen he has applied over there. This screen where he finds out point A, point B, and a point C, where he applies a magnetic field. Okay, two kind of fields were applied here, north and here south, here positive and here negative. So when he applied a like this, the rays were passed over there. Here we have one negative, positive, negative, high voltage current. This is my cathode, this is my anode, this is electric field, and this is the plus positive and negative, that is called a magnetic field. Okay, I'm not able to draw it in a proper manner, but yes, you can see this is what the magnet, they have kept it over here. So what you find, when there is no electric field, that strike exactly straight away, but when it is an electric field is applied, it going towards A, and when it is magnetic field is applied, it's going towards C. So these are the 3 points he got it. So with the help of this, Thomson argued the amount of deviation for the particles from their path in the presence of electrical field depends upon, number one, the magnitude of the negative charge on the particle greater than the magnitude of charge on the particle. Greater is interaction with the electric or magnetic field. He says that whatever the magnetic field is applied over here, whatever the magnitude, their particles are having very, what we can say, they are having a greater magnitude of the charge of the particle. It means that's why they are moving to that side. The mass of particle lighter, the particle has a greater deflection. And the third point, he says, the strength of electrical or magnetic field. So these are the 3 points on which he has derived, and then across an original path, and then he says that by carrying out an accurate measurement deflection, he comes to know the ratio about this is E upon ME. This is what E upon ME is the ratio, which comes out as 1.7558820 into 10 raised to 11 coulomb per kilogram. Okay, now what is this E? E is a charge. અને બેટા સમજી લેવાનું કે ચાર્જ ઓફ any કોઈ બી XYZ ચાર્જ ઓન ઇલેક્ટ્રોન ફાઇન્ડ કરવો હોય આપણે તો કેટલો ચાર્જ છે? તો કે ચાર્જ ઓન ઇલેક્ટ્રોન ઇઝ ઓલમોસ્ટ -1.6022 into 10 to the power -10 coulomb છે. Okay, અને mass of electron that they have found it out was 9.1 into 10 raised to -31 kilogram હતો. આ બંનેનો રેશિયો લીધો તો એને આ વસ્તુ મળી હતી. So this was happened, and then since the electron are negatively charged, the electron charge on electron is always negative. So this ratio and this was the charge which was given by Millikan experiment, oil drop experiment, which we are not going to discuss more about it. So guys, this is the only things which we have to talk about, how the discovery of electron takes place. The same way the cathode rays was discovered, and that canal rays comes over there in existence. Now canal rays was about whom? So the canal rays, that electrical discharge. Now here comes a one scientist whose name was E. Goldstein. What he suggested? He suggested that along with this, as the cathode ray tube, same as the cathode rays are coming out, certain other rays are also coming out, which is known as anode. Okay, they comes out from an anode, and this electrical discharge out modified cathode ray tube led to the discovery of canal rays, positively charged particles. What happened that they are the same one. Unlike cathode rays, the mass of positively charged particle depends upon the nature of the gas of the cathode ray, and these are simply the positively gaseous charged ions. So the mass ratio also depend on this thing. So what happened that later on they come to know that these canal rays are positively charged, and they are nothing but they are given name as a proton. The positively charged was characterized in 1919, and the smallest and the lightest positive ion was obtained ever. આને કોની જોડે સરખાયો? So they have talked about hydrogen atom, because that was the lightest and the what we can say, it's the smallest ion which we are having, hydrogen ion. This is what hydrogen ion. So proton was considered as that, and this is how the experimental canal rays comes out from the same tube. Modified experiment done by the Goldstein to gives you positive canal rays are positive than a cathode rays. And guys, this is how the discovery of proton takes place. Then comes a Chadwick. Okay, James Chadwick. Okay, the very nice experiment done by him was like that. He bombarded alpha rays, okay, the sheet of beryllium. Chadwick. The name of the scientist was Chadwick. Okay, the Chadwick was the name of the scientist, and this Chadwick was very nice one. Chadwick fellow. The Chadwick has bombarded beryllium by alpha particles. Basically these alpha particles are nothing but they are the particles of helium, and then when electrically neutral particles having a mass slightly greater than the proton were emitted, and that's what he comes to know. He named them as a neutron. And guys, this is how the very important thing that comes out. What are we supposed to learn from this section? તમારે ખાલી આટલું જ યાદ રાખવાનું છે કે 3 subatomic particles આવ્યા. The subatomic particle, one was electron, one was proton, and the last one was neutron. This one was discovered. The symbol of electron is small e, proton is small p, and neutron is small n. And the absolute charge, the charge on these particles are, this is -1.6022. આપણે આટલું જ લખવાનું, બીજું બધું યાદ નથી રાખવાનું. into 10 raised to -10 coulomb. આનો સેમ જ ચાર્જ છે, બટ એની સાઇન ઓપોઝિટ આવશે. okay, 10 raised to minus 10 charge of the coulomb, and this one is neutron, does not have any charge. અને આના રિલેટિવ ચાર્જ જોઈએ તો એકબીજાની સાથે રિલેટિવમાં મૂકીએ તો આનો નાનો રેશિયો કાઢું તો આ -1 આવે, આ +1 આવે અને આ 0 આવે. ઓકે, આનું માસ પર કિલોગ્રામ આપણે જોઈએ તો when I talk about a mass per kilogram, so what is the mass of this? So I'm going to write down 9.1 into 10 raised to minus 31 kilogram, very 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 small in the section than the proton. Whatever the proton we have, okay, it is called a mass. It's 1.67. okay, I'm going to write down only 2 digits, which is very very important, into 10 raised to minus 27 kilogram, which is heavier than electron, and the same mass is carried out by but little bit more, 6749 into 10 raised to minus 27 kilogram of neutron. And dear students, only the mass of atom is considered by proton and neutron. The mass of electron is very very negligible, which is far away from us, and that's what they have given, and that's why the approximate mass we consider approx, whatever that approx mass. This table is only important for you, nothing else is important for you. Okay, so this will be 0, this will be 1, and this will be 1. So guys, these are the all things about our discovery of electron, proton and neutron. So in the next section we will see the structure of atoms given by different scientists. Thank you.